All right, this is Horner again, and we're going to go through number 31 through number 40 for the 1D Kinematics multiple choice pretest for this year. The first question here says, during the time that the acceleration of a particle is constant, its velocity versus time curve is, so we need to figure out what does this look like. We know that the acceleration versus time curve, so we'll go ahead and make the positive and the negative side here. Let's just make an acceleration versus time. And if we draw it like this, it has an acceleration, which means that the velocity versus time curve needs to have some sort of slope. And so it probably will look like this. It's got to be a straight line. It cannot be a parabola. Remember, typically for these, velocity versus time is always a straight line. The position versus time would be different. That one would definitely be a parabola, so that's position versus time. But for velocity versus time, it's either got to be a straight line up, a straight line down, or a straight line across. And the one that matches with this set of graphs has got to be the one that is a straight line coming up to the right if we're doing it with this kind of acceleration. For number 32, this one says, suppose that a car is moving to the east in the positive x direction. So we'll draw my little fantastic car again. We'll put a hood on the front here, put a little window there. And this car is moving in this direction, so we're saying it's positive. It begins to slow down. So if we're doing a velocity versus a velocity map for this, you would see something that would look very similar to this. And our acceleration then would have to be in the opposite direction. So we're going to go similar to something like this. And that would be kind of how it's done. So the acceleration, because it is going in the opposite direction, so our velocity here we said was positive in the east, our acceleration would be negative or go towards the west. And the answer for this one, the acceleration is negative, is really what we're looking for. For number 33, this is the next question. It says, suppose the car is traveling to the west. So now we've got it going the other way. So here's our car again. This time here's the hood. The car is actually moving in this direction, and so it's going in a negative direction, which means our acceleration has to be going in the opposite direction because it is slowing down. If we do a velocity map for this, we would have a long line here, and then it would get shorter as we go because remember it is slowing down, and that would slow down to a stop. Our acceleration then, let's get rid of what's on the bottom here so that we don't confuse ourselves. This is our velocity map. Our acceleration map would be the acceleration would have to be in the opposite direction since this item is slowing down, and it would be constant all the way across. So the acceleration here would be positive since it is going to the east if we make west negative. For number 34, an object is moving with a constant non-zero velocity in the positive x-axis. The position versus time graph for the object is, so we need to go ahead and do position versus time. Non-zero velocity means that it's got to be either positive or negative, and for this one it's positive because it's moving in the positive x-axis, so it's moving towards this direction altogether. So for number 34, it'd be a straight line making an angle, so we see it's up at an angle with the time axis. For number 35, this is the next one. An object is moving with constant non-zero acceleration in the positive x-axis. The position versus time for this one is, so here's our position, here's our time. Let's think about the velocity versus time first. The velocity versus time, it says constant non-zero acceleration. So acceleration versus time would be here. So it's constant non-zero, and because it says it's going in the positive x-axis, we know it's got to be positive, which means that this graph has to be a straight line, which means that this graph has to be a curve. And so the position versus time graph for number 35 should be a parabola, so a parabola. For number 36, It says an object is moving with a constant non-zero velocity and positive x-axis. The velocity versus time graph, so now we have velocity versus time graph, constant non-zero velocity. So if it's constant, it should just be a straight line, which is horizontal. So we have a horizontal straight line. It could be above because it is in the positive x-axis. We'll say it's above the line there. For number 37, this one says an object is moving with constant non-zero acceleration in the positive x-axis. So here we go. We have acceleration versus time, positive x-axis. The velocity versus time of this object should be a line that goes like this. So this is velocity versus time. So for number 37, your answer would be a straight line making an angle with the time axis. For number 38, if the position versus time graph is a horizontal line, so we're going to draw a position versus time, and we have a straight line, this object is standing still. Standing still. And so that is number 38. Another way to say standing still is it is at rest, and that's really what they want. And that is answer letter C. Number 39, if the velocity versus time graph is a horizontal line, so here's velocity versus time. If it is a velocity versus time, it would be moving with a constant non-zero speed. And so constant non-zero speed would mean that could either be above or below, because the speed would be non-zero. The velocity could be positive or negative. But if we have to describe this, that's why they say it's moving with a constant non-zero speed. The next question is number 40. This is the last one for this section. It says that the velocity versus time graph is a straight line making an angle of 30 degrees with the time axis. So we could do this. So this is velocity versus time. We would say that this object is moving with a constant non-zero acceleration. So this one has an acceleration because we have a change in velocity over a change in time. And that is number 40. And the next section that we'll do is number 41 through 50.